Hello, everybody, and welcome to the Transmission Podcast. It's me, Quentin, and this week we've got Shyam, CEO and co-founder of Zitara Technologies in. Now, Shyam comes from a company before this that I really admire. It's Nest, who make the thermostats that we all know and love and got bought by Google. And now they're doing battery analytics software to figure out how to get the most out of assets and make more money with them. So, really enjoyed this conversation. We talk a lot about hardware and software at the edge and what that really means, and the impact that this kind of software can have on asset owners and ultimately the returns for battery assets. So, if you like this one, please do hit subscribe and like and put a comment in the comments. It really does help us increase the reach and get to more listeners. Let's jump in. Shyam, thank you for joining us on the podcast.
Quentin, good to see you.
So, Zitara, should we talk about that to start with? What is Zitara?
Yeah, absolutely. Zitara, we've been around for about 6 years. We're a 35-person company based here in San Francisco, and we're focused on real-time edge monitoring and controls for BESS. So we try to make your BESS more profitable, safer, and last a lot longer.
And how do you do that then? So what do the 35 people do? Are they software engineers or are they other types of engineers?
Yeah, primarily we have two categories of engineer at Zitara. Software engineers that build controls, so controls experts. A lot of our team comes out of kind of the autonomous driving world. So we are really experts at edge controls and cloud edge controls. But really the other half of our R&D team is battery modelers and algorithms experts. So we get really deep into the chemistry of batteries, and that's what allows us to control them better at the edge.
And what's the reason that, I mean, we've had a couple of battery system analyst companies, if you like, or analyst software companies on, and they've done a really good job of answering this question. So I want to ask it to you as well. What's the reason that a customer, say you're a grid scale, actually, I'm going to do this differently. Hold on. I'm going to edit this bit out. And so we spend our whole life on this podcast talking about grid scale batteries, which is, of course, a massively growing market and lots of different types and chemistries and blends of batteries and battery systems out there. So for a owner of energy storage assets, what's the advantage of coming to Zitara versus going to the original equipment manufacturer, say Samsung or Panasonic or CATL?
Yeah, absolutely. Well, across the board today, we've seen kind of the dominance of one chemistry, and that's been the last few years of LFP batteries being by far and away the cheapest option for grid scale. They are notoriously difficult to manage. Especially as the formats of these sort of these cells and the choices start to get larger and more consequential. We see different kinds of effects make it harder to tell how much power or energy you have at a given time, even all the way down to the cell or rack level. So you could look at one of these sort of uh, uh, battery voltage curves and kind of compare LFP to previous technologies like NMC or in the cell phone era LCO, and you'd see kind of nice linear curves for previous chemistries that told you,
And is
for a particular state of charge, how much voltage you should expect.
and is
Much
this
more
because
difficult.
systems they measure voltage as a proxy for state of charge? So when your iPhone tells you it's got 90% or 85%, the way it's doing that, amongst other things, is actually measuring voltage and then looking it up on a little chart.
Exactly, yeah. If you want to get to looking it up on a little chart, you often have to let that battery idle for a little while. And so then, even more complex is trying to suss out while you're using the battery, while you're doing that discharge, how much more voltage drop has happened because of the discharge. And so, if you can back all of that out while the battery is discharging, then you can tell how much power and energy you have. It turns out your OEM systems are often 20 to 30% off during a discharge.
Wow. 20 to 30%. Is that 20, 30% error, I guess?
Yes, that's right. All the way down at the cell level. And you'll see corrections come out to the telematics that end up getting reported for your market operation or for, for your for your ISO. Um, so, you'll see smoother signals at the site level. But if you drill down and look at, individual inverters or racks within a BESS, you can often see these 20, 30% jumps frequently.
And so measuring state of charge or the percentage of energy in a battery, to keep it simple, why does this even matter? Why is this so important?
Well, it depends what you're trying to do with your battery that day, but almost no matter what, more hours of power translates to more revenue on the whole over a long period of time. So, our customers, they may be trading energy wholesale, so they'll have a sort of day ahead activity, and then a real time activity on the next day. And if you bid the most aggressively you possibly can day ahead, you're not going to get necessarily awarded all of that energy that you've put up for sale. During the day, you really want to know, especially kind of towards the end of the day when prices might be peaking, exactly how much you have left in the tank. And the real time signals that you have to do that today, if they're inaccurate, you're either, incurring sort of opportunity cost by not trading as aggressively as possible, or you're ending up, with a base point deviation in a market like ERCOT, or other penalties for not being able to serve what you've committed.
And we talked. Sorry. And when you at the beginning of this conversation, you talked about this problem getting worse. So the change in chemistry over time from, let's just do it most recently, from NMC to LFP, which is now the dominant battery cell that's being installed around the world, for all the good reasons about supply chain, input materials, cost. But if I read between the lines, you're saying that actually measuring state of charge from voltage of LFP cells is more challenging than NMC. Is that correct?
Yeah, that's right. Well, with any battery, I think once they're old, cold, or under load, we like to say that they're more difficult in those moments. Um, but with LFP batteries, we're seeing shocking problems just on day one, where you might expect a few years before you have problems on previous chemistries.
And so, how do you guys do this better than the original cell manufacturers? What's the secret sauce?
Yeah, well, it's not really even cell manufacturers that have specialized in this to date. Um, Largely, we think about cell manufacturing as this incredibly complex chemical manufacturing kind of miracle. If you've ever been to a battery factory, it's a very, clean room facility, more complicated than manufacturing silicon. What a thing. It turns out this is a wholly separate skill set than writing software. Today, you may see a module maker in the middle of the value chain being tasked with, provisioning a battery management system hardware and usually getting the software just kind of on board that BMS by default. These are often some of the most profit squeezed players in the battery value chain today, and they may be focused on just razor thin margins for assembling those cells into a module, but they're really not putting a lot of R&D into the equation. Additionally, they don't really have any LTSA or contract or warranty associated with the performance of the algorithms on the BMS. Usually an availability contract says my inverters or some percentage of the inverters in my system need to be up and functional, but nowhere does it mean that 50% SSE means I have 50% of my energy. Usually not in the contract.
And when do you guys get involved? So, say I'm an asset owner, I'm going to build a I've got existing assets operational right now, or I'm considering building a new one. When do I say, right, I've got to call Sean and get his team involved?
Absolutely. Well, today we're focused on retrofits. So we'd love to talk to you if your, max power, high sustainable limit readings from your LFP battery are noticeably wrong. You're running into base point deviations. You've noticed that the SOC is not accurate, and you care about your trading clearing, as expected. We think about it kind of as a market clearing problem because when you submit that day ahead offer, you're including SOC pairs with your power and price. And so if your SOC is 10% off, that means that your bid isn't clearing correctly. So if you run into those kinds of problems, we'd like to talk to you. We also love to engage more greenfield projects. So when you're at about your 30% completion mark, we do love to come in and audit your networking diagram. This is just sort of a service that we like to provide. We think that it's very important if you're constructing and planning to own and operate that you have access to the right data and that you have access to the right control. And so 30% is right about the time when we can, get ahead of any issues. But then we got to wait until the asset's operational to really help.
But you have going back to the first thing you said there, which is that if you're an asset owner and you see these kind of errors or you're seeing deviations, then then pick up the phone. The thing is being able to see those things in the first place, right? Because you've got measurement challenges compounding on top of each other. You think about, I'm sure you know this already, but measuring, what do you measure at the cell level, at the rack level, what does the BMS see? And then you've got balance of plant and transformers, and then you get to the boundary meter, the settlement meter. There's a lot of losses and noise in between those things, and you get paid on the boundary meter, right? So, how can folks think about, they own and operate assets, making sure that how do they measure that? What should they be doing or thinking about to make sure they can find out whether the data is right in the first place? What's your guide?
For sure. Well, this is actually something that we use the Moto tool for, and we're going to be getting on board with that really soon. We're really excited. We look for places where people are either generally underperforming the market, but if we can get down to time series, we're looking for places not just where people had base point deviations, but where they appear to have purchased energy at high prices unexpectedly. So particularly, in markets where the customer might have committed to something after a peak event, that's a really really costly day. What we see happening is prices start to tick up during the day. The customer starts to discharge their battery, and then their state of charge or state of energy reading uh, probably goes down faster than anticipated. The way we can tell is that maybe because they have an ancillary service or something committed in a future hour, they end up purchasing energy at this peak price. So, putting aside base point deviations, the fact that they ended up purchasing energy at, in Texas close to the peak sometimes, this can wipe out weeks or a month of profits to just have had this one event. Um, what we tell customers to look for and an analysis that we'll do for free for you, we'll do a complete analysis for you in terms of the accuracy of your signals. So if you want to understand your balancing state, your state of charge, your state of energy, your power signals, which ones are accurate or inaccurate, you can send us data and we'll figure it out. But a key place to look is to say, my system was reporting that I had 100 megawatt hours at this time. Then my revenue grade meter told me that I put out 50 megawatt hours over the next hour. If my state of energy says less or more than 50 megawatt hours by quite a lot, that's where we start asking questions, if that makes sense. So we compare for that SOC, does that well reflect actually the percentage of energy in the asset when you compare it to what went out on the revenue grade meter, especially if you can correct for things like auxiliary loads that you mentioned.
Yeah, I mean, everything comes back to that network diagram that you mentioned at the beginning. How about access to data then? Because I just think it's absolutely terrific that we have companies like you guys, and there's some other European folks doing similar, who are really challenging what is possible with the data versus the OEMs. I think it's absolutely brilliant. And yeah, by being highly specialized, there is an argument that you can really add a lot of value versus the OEMs. But do the OEMs play nice? And don't you need access to data? Because historically, a lot of our customers who own assets, they're surprised by how, in some cases, some are really sophisticated, but many cases they're surprised how little access to data about their own assets that they even have. And you'd think that in this day and age, if you spend $50 million on an asset, then you've got a right to see under the hood. But that's not always the case. So yeah, are the OEMs playing nice? What do you advise companies put in their procurement and construction contracts? And how do we create an environment where all this data is open for companies like you to come in and really make a big difference?
Yeah, absolutely. Well, there's one notable vendor in the space that's particularly closed with data, um, and that's Tesla. Probably not a secret. Um, we outside of those kinds of projects where honestly we've steered our customers to looking at evaluating us on non Tesla sites, of which there are many. You know, uh, uh, we've never had a problem with an OEM not wanting us to have access to particular cell level or battery data. It ends up working out to much more of an IT challenge. If the site hasn't been configured to be getting access to the most granular cell level data, there may be elements that just sort of average or downsample that information along the way out to your historian. And it's a matter of wrestling with your sort of integrator or supplier chain to be able to get access to that data. Um, what we have seen, though, is that more modern systems and things that are getting constructed today, the data architecture is generally more modern and it's easier to get access to whatever data you'd like. When we look at assets that were constructed in 2021, 2022, again, it's not that anybody doesn't want us to have access to the data, but sometimes it's a pain in the ass.
Yeah, and then the last thing you want to do is start demanding that there's a cost element too, and customers, asset owners don't want to have on-site servers or really high bandwidth connections for cloud storage and all the additional costs there. It becomes, like, is it even worth it? So this era, can we come back to this era, this state of charge era? Does it get worse over time?
Yes, absolutely. So generally, what we're looking at is the state of charge of individual cells within a rack, but there might be 400 cells adding up to your DC bus voltage within that rack. And you're limited by the state of energy of, during discharge, the lowest cell in that stack. Now, that could be the most degraded cell in the stack. It could be the cell that had had the most, temperature and therefore had leaked the most internally. It could be the coldest cell in your stack that is actually going to hit its voltage limit before the rest. So at any given time, your algorithm is actually trying to figure out which of these 400 cells is going to limit that rack. Then behind whatever your kind of AC topology is, when are different AC blocks in your system going to turn off? And so depending on how you've configured things, you might have thousands of cells, and you're actually trying to guess which is the one that's going to limit you at any given time. So as your cells degrade, you anticipate there being more variability from cell to cell, and then it becomes that much more complex to figure out which one's going to be the limiting one. You mentioned, uh, the sort of bandwidth and the data connections. This is definitely exactly where Zitara tries to solve that problem. You know, in a particular site, there's 400 cells in a rack. We might be looking at 10,000 cells or, tens of thousands of cells in a system. And the way that we address this in order to be real time is actually exactly the way you said. We put a server into your cabinet and we live primarily on board that server. This means that, we don't have kind of a dashboard or analytics services the way that some of our friends at Twice or Acure do. We're just the controls and we're replacing the signals that you're using in your existing system. So, however you are getting data off of your EMS, however you are using those for market operation, and then whatever telematics are coming from your EMS and going into your cloud, going into your ISO, we are replacing those directly at the edge. And that means that we need to be on prem in order to be real time, in order to be able to soak up all that data quickly enough, but then also to be compliant. You're not allowed to use cloud solutions in the loop for dispatch. And so we fit right into your NERC case with our kind of secured server.
So you're physically going on site with a big metal box and putting it in a server rack somewhere.
That's exactly right. On a per kilowatt hour basis, this is much cheaper than getting the data off.
So I want to come back to a hold on. So a hot topic at the moment in our world is cell balancing. There's just been so much change and improvement and iteration in how systems are balancing cells. And I know that you and your team spend a lot of time thinking about this. Could you just, for our audience, just go straight from the top? What is cell balancing and why does it matter? And how are you guys thinking about this problem?
Yeah, absolutely. Well, cell balancing in a system that's brand new, where all of your cells are identical and have all started at exactly the same state of charge, should be a non-issue. Uh, Unfortunately, right after moment one, this idea that every battery has the same capacity and that every cell is at the same state of charge goes right out the window. So, as I mentioned, uh, behind a single rack where you've stacked 400 cells in series, and then depending on your AC topology behind that, you may be limited by whichever cell in that system has discharged to zero faster. And that may be because you can't discharge more of the cells while you're limited by one. The simplest example is in a single series rack, you can only discharge the cells together. Now, this cascades up the system, right? We have racks that are organized into DC buses that then kind of might connect in different configurations to a PCS to form an AC block. And depending on how many of these AC blocks are in your system, as well as what controls you have behind each one to balance across different racks, you're going to have different limitations at any given time in your system and different trade offs to take those batteries down and allow them to balance. So, typically, what we're seeing from OEMs today is that in order to trigger kind of a balancing condition, you often need to bring that battery all the way up to 100% or all the way down to 0% and let it idle in order to trigger balancing. And this is because with those LFP batteries, the very top and the very bottom, there's a little bit more observability into the state of charge because those voltage curves are a little bit friendlier. Um, if you choose the wrong subsets of your asset to take down for this balancing activity, you won't be improving the performance of your battery. And you may be actually leaving a lot of sort of opportunity cost on the table by picking the wrong element to balance. But because you have to go through this sort of onerous exercise of taking that rack all the way down to zero, it is very critical to pick the correct element of the system to balance. If you do this systematically and hit the out of balance racks with this balancing activity consistently, and it can take a very long time to get back in balance, then you can actually maximize the range over which you have max power in your system. So if your cells are, 20% out of balance, you might find that you can only get your max power between 10 and 90 in your system. And we find that 10% is a very common figure for how much out of balance your system is. But over time, you might actually be adding 1 to 1.5% mean imbalance per month, and your present balancing strategy may or may not be addressing that at all. So we'll see, customers that have worked with their OEM for a long time instituting some of these new approaches to balancing, but the mean balance is still steadily drifting up at that 1.5% a month, and they're getting less and less of their actual max power band.
The operational challenges of managing these big batteries are it's just fascinating because you have measurement you have measurement problems like we've just talked about, ranging from the granularity of time series data to where it's actually being measured. And then you have these operational challenges. Once you've measured it, you're not sure whether it's right or wrong in some cases. And you have these operational challenges about real physics, about different cells having different voltage curves. And then operationally, you have this compounding problem of balancing that every month is getting more and more challenging. And at some point, you have to kind of rip the Band-Aid off, go down to zero and go back to full charge, which is expensive and comes with it's an opportunity cost. And figuring all this out is just fascinating. And so, how do you guys approach this problem then? If you're thinking about balancing a data led approach to balancing, what would you advise asset owners to think about?
Yeah, absolutely. We think asset owners should think about automation and intelligent automation. So, the worst case scenarios we see today, we have asset owners that have to take their entire site down in order to perform this balancing activity. The better sort of EMS systems that we're seeing out there today enable customers to go PCS by PCS, take a partial outage, and only balance part of the site. But what we think is really merited is what you get when you install Zitara, which is a prioritized intelligent balancing system. Number one, we're giving you real time observability into the state of imbalance behind every one of your AC blocks. So that's not only critical to knowing how much power you have right now, but if you go through this activity today, we're the first time you're getting feedback on how much you've actually unlocked in your system. And so, ultimately, that's best for setting up automations. That means that you can identify which blocks are costing you the most hours of power, make sure that those are balanced whenever there's an opportunity. And then we want to configure things like making sure that we take advantage of time when you're not planning to use that asset, or where the costs are low for taking that one PCS down, and automatically just have the asset always optimizing itself. Because it does take really a long time and persistence to get these things back in balance. We just think you need to be taking every possible opportunity. Typically a battery is only really making money for 6 hours a day. So we want to use the rest of the possible time.
And my last question before we get on to the standard last two questions of the podcast. So if you were some of our listeners, well, many of our listeners are asset owners and operators. So whether that's funds or utilities, companies and folks at these companies that really know operating real asset. Let me start again. Hold on. And so, can you do me a favor? Can you, for our audience, who is primarily folks who own and operate battery systems, and grid scale assets, maybe already online or are developing and financing these, at the contracting stage, what should they be adding into the contract? What's the bare minimum for data requirements that they want to make sure is in the contract? What's your kind of 101 guide for that?
We get this request quite a lot, and we're going to be publishing something here in the next month or so, hopefully. We think that there's a key SCADA points list that is really important for making sure that you're monitoring your power reliability as well as your safety. And that's a big topic this week after what happened at Moss Landing. We think it's really important to ensure that if you want you should be able to go in and get access to high granularity cell level voltage data. And if possible, this should be historized, not necessarily taken off of the asset and into cold storage, but you should be able to get, pretty high granularity voltage data from every single cell in your system. Now, not every customer of ours puts a large enough historian on their system to be able to do this. And so, at the very least, they're getting the min and max voltages from each rack. And for a relatively new system, this would be okay. But this is perhaps the most important thing in addition to the current or power ratings from each rack in your system, as well as the temperature readings that you're able to get your hands on. If you have a problem, it's very critical to be able to go back and pull that data that's only at the edge and use it to be able to debug, why did I have a safety issue? Why did I have that base point deviation? If you're not doing it already today, we highly recommend it.
Yeah, you need to store the boring data when nothing's happening, um, just for when something does happen. Okay, now to the last two questions. So, firstly, Sham, is there anything you'd like to plug for our audience or our listeners? It's generally battery energy storage, grid scale battery energy storage folks from Europe, the US, and Australia.
Yeah, I think just to pay attention to what we're going to be launching this month at Zitara. So we are coming out with our best owner operator focused solution. This is our on prem box, and we'll have a couple different flavors. Our on prem real time solution for soaking up all of the data that you need, historizing it correctly, and spitting out replacement real time signals that you can use for market operation. So we think we're the only solution on the market that actually does this on prem real time. We'll also have a big announcement with our kind of corporate partner, Emerson, related to Zitara Live being available to customers of the Emerson Ovation DCS system. So stay tuned for that.
Very cool. And also, you're doing hardware, which is great. Hardware is back in vogue finally. As an engineer, I'm so happy. It feels like startups everywhere are getting back into doing real things in the real world. Um,
Absolutely.
very,
We
very
don't
cool.
design the hardware itself. It's just a hardened, Dell server. But ultimately,
Well, I'll give you the
yeah,
kudos anyway.
I appreciate it.
And Sean, what's your contrarian view? What's the thing that you believe that not a lot of people do?
Yeah, we think that battery signals can work at the edge. And I think we see so many different sort of folks out there that provide cloud analytics. And what we think is really underloved in the world today is things that you can do onboard hardware directly at the edge, because
When
this
you
is
say
where
the
all.
edge, what is for folks who aren't in the in this world? What is the edge?
Well, the edge it's basically two things. One, it's the idea that you don't need to transfer data from your site, from your premises, across the internet to get anything done. We can do all of the computation and analysis of that data directly on premises at your site. So the edge is the ability to do that with limited compute. We're not using a supercomputer in the cloud, but also it's the ability to do that in a secure and compliant way that doesn't open you to any kind of, you know, vulnerability or threat. And so really a lot of the reasons that we're doing edge compute, it's really twofold. One, we can get access to so much more data without paying the data transfer costs. And then two, it's for cybersecurity and resilience. Often for your NERC SIP case, if you really wanted to solve this problem, you're not allowed to use a cloud solution. You have to use an on-prem one like us.
It's funny, there seems to be, there was in the last 15, 20 years, there's been a huge shift to cloud. Everything's moved to the cloud, and that's been enabled with, 3, 4, 5G over that period. And it's pretty much in every sector, you're seeing a move now to cheaper compute on chip and not bothering to send stuff. So, for example, a lot of you only have to look at consumer electronics and the use of large language models, and the way that you can squeeze models down now to run locally, and all of the security and privacy benefits of that are immense. It'll be interesting to see whether this decade we see a switch back away from cloud and back to people doing compute themselves. Um, AWS has had one hell of a run, growing like 15, 20% year on year forever. So maybe their time has come to an end.
Maybe, yeah. I think that it's always been a partnership, and maybe it's about that privacy element in the end, right? Maybe you could get the best performance with a cloud model, but if it's really important that you stay secure, or if you don't want your data going up to the cloud, then it's always been really important to have that edge compute. I was fortunate to be one of the first few hardware engineers at Nest to start my career, and we were definitely a pioneer in the IoT space, making a distributed resource available through a cloud API. But I think the thing that everybody cared about was making sure that their data about their preferences, how they moved in and out of their home, that kind of thing, did not go up through the cloud service. And so we had to figure out how to marry what you wanted to do locally in order to be private, with what you could do to make the resource available to the grid. And so I think we're seeing that scaled to front of the meter assets now, which is just wild and really enjoyable.
And what was it like building? Let's do this. What was it like building Nest? I think everyone who has a Nest absolutely loves it. It's just by far the best product. It looks the part on the wall. It was so awesome when it first came out, and even now they are. It is the leader, right? So if you were involved at Nest in the early days, what was that like?
For a kid coming right out of college, it was the best possible experience in the energy industry. I think it was this moment of real optimism. And we saw, utility companies jumping on doing pilots with us, because I think people loved, delighting their consumers. And it's so rare for a utility innovation office to be loved, by their consumer, by providing them such a beautiful object. But I think the trick was, how do we actually start to make firm resources out of distributed networks like this? And I think, edge intelligence became a real part of that. And, you know, I think everybody's kind of surprised the batteries weren't so firm. So it's
Yeah.
surprisingly, the idea of using edge compute to understand what's happening at the battery, ended up being necessary as well. So it's kind of full circle for me.
Very cool. Well, Sham, I want to say a massive thank you for joining us on the podcast. We'll put some links to all the stuff that you guys are doing in the show notes. So if you're listening to this and want to check them out, please do. And when I'm over on the West Coast, I come by for a beer.
Absolutely. Yeah. Everybody should come visit our battery lab in San Francisco.
Awesome. Thank you very much indeed. See you soon.
Quentin, thank you so much.